Hello and welcome to the channel Understanding Concepts of Physics. Today here we are with a topic called oscillation. We have been starting now, and this would be the first video in the video series of oscillations, and this is going to be a very long video series because oscillation as a topic is a pretty huge section. So be with me in the entire playlist, in the entire series of these videos. It's a very mathematical chapter. If you just skip one of the videos and just jump onto the future videos, then I guess you might face some issues in understanding the equations of oscillations in the due course. So let's just quickly start with this chapter called as oscillation. Now before we start with oscillations, we need to understand that there are certain terms and terminologies which we need to take care of. So let's just quickly begin, but before going to oscillation, basically we need to also understand what are the examples, real life examples where we see oscillation in daily life. So as you can see on the screen, the motion of a swing is a kind of a pendulum. So a swing or a pendulum is basically hanging from a rigid support, and there is this string and a heavy bob which is just hanging on this, and the pendulum just keeps on going back and forth. So the motion of a swing or a pendulum is basically an example of a oscillation. So oscillation is basically kind of a motion, and it is also sometimes called as vibrations, and we have another name for this kind of motion as well. We are going to see it very soon. So motion of a swing, the kids playing on the swing in a park is basically an example of an oscillatory motion. It's a kind of a pendulum in which the child becomes the bob. Strings of a guitar. So if there's a guitar and if this is the guitar string, then if you plug the string from the center, then definitely this string is going to vibrate up and down, and this vibrations is basically considered as oscillation, and oscillation has to be considered over equations of oscillation can be applied over the strings on a guitar. Then comes atomic vibrations. We have been discussing kinetic theory and thermodynamics in so many videos, and as we know, all the molecules are in a constant random vibratory motion. So molecules are continuously in vibration, and these atomic vibrations are also basically considered under oscillatory motion. Then comes needle of a sewing machine. So if you have seen a sewing machine, then the needle, where as soon as you press the pedal, the needle just keeps going back and forth, up and down, and this is basically oscillatory motion, under classification under the oscillatory motion. Then the last example is motion of a shock absorber in a vehicle. So as soon as the shocks are experienced by a vehicle, the shock absorber, the springs in the wheels and the axles of the vehicle, they just keep on going up and down, and this motion of shock absorber in a vehicle is also comes under the oscillatory motion. So these are certain examples in the real world where we experience oscillatory motion. You may just club down some more examples as well in the comment section if you find few. Next is that every motion has its own equation, and oscillatory motion will also have its own equation. But the most distinguishing factor in oscillatory motion to other kinds of motion is that in oscillatory motion you experience the terms of sine and cosines. So when you have terms of sines and cosines, these sine and cosine in mathematics, this sine and cosine are called as the harmonic functions. And the reason it is called as a harmonic function because the values of sine and cosine are just repeating. However, this does not happen for other trigonometric functions. Like if you consider tan, if you consider cot, you consider cosec, or you consider sec, all these functions do not repeat itself. Like the value for tan, for the sake of example, goes from minus infinity to plus infinity. But if you see sine and cos, they will always hover between -1 to 1. So the value of sine, the minimum value of sine is -1. Whichever angle you take, you will definitely come to touch -1 at one point and +1 at other point. Even that goes for cos as well. So the values of sine will always remain between -1 and 1, and that's the reason why this is called as harmonic functions, because they are repeating their values again and again and again and again. Now, because oscillatory motion consists of harmonic functions, it is also sometimes called as harmonic motion. So oscillatory motion will now be called as harmonic motion, and this harmonic motion is a very big class of motion. You have further different types of harmonic motions, and of which we are going to discuss in our series two of the very special type of harmonic motion, and that is linear. That is, the motion should be in a straight line. Simple harmonic motion. So because if there is a simple, there is actually a complex harmonic motion as well, but we are not going to discuss in this course. That's not a part of the syllabus of what we are going to discuss in this video series as of now. So simple harmonic motion is basically we are going to discuss, and that too in the linear as well as in the angular. So in angular, the oscillation is in the form of like back and forth, like something is rotating clockwise, then anti-clockwise, then clockwise, then anti-clockwise, then clockwise, then anti-clockwise, like that. That's what is called as an angular simple harmonic motion. We are going to discuss this in further detail in coming few videos. Yes, definitely it will take some time, but yes, we are going to discuss. So these are the two topics we are going to discuss in the entire harmonic motions. Now this is just a basic introductory video where we are about to see what oscillation is. I would like to also cover one of the more topics called as periodic motion. Now periodic motion is a motion which repeats itself after equal interval of time. So a motion which continuously keeps on repeating itself after equal interval of time is called as a periodic motion. So the motion which repeats itself after equal interval of time is called as periodic motion. And there are two examples here. There is a uniform circular motion. So a particle which is going round and round along the circumference of a circle with a constant speed is what is called as uniform circular motion, and this uniform circular motion is a periodic motion because it is repeating itself again and again in equal interval of time. Or you can take motion of a swing. The swing actually just keeps on going back and forth, back and forth. It repeats itself after equal interval of time, and that's the reason it is called as a periodic motion. So periodic motion is what we have discussed in this video, and hope you have enjoyed this video. And we are going to discuss a lot of math and a lot of equations, diagrams and derivations in this chapter. Hope you are going to follow those videos. In case if you have not subscribed my channel yet, subscribe the channel in case you haven't, and keep watching the series of all the other videos as well. Thank you so much. Have a nice day. Bye.